Hello students, welcome back to my channel JPPHYSICS. In today's lecture, we are going to discuss about vertical circular motion. See, I have told you that I am going to make the series of videos in which I am going to do the derivations for 3 and 4 marks, which are frequently asked for your 12th board exam. Correct? From that only, this vertical circular motion is one. Okay. See, in rotational dynamics, there are 4 derivations which are repeatedly asked for previous questions, that is for 3 and 4 marks. Means this is vertical circular motion, another it is parallel axis theorem, third one it is law of conservation of angular momentum, and last one it is expression for kinetic energy of rolling body. These 4 derivations I am going to do for you. Besides this, there are also 2 derivations which are frequently asked, that is V is equal to under root mu s rg and V is equal to r omega. But these derivations I have done in previous lectures, previous videos. If you want that lecture also, you can go to the description box. You will get that link for the videos. Okay. So let's start today's derivation, that is vertical circular motion. See, in case of vertical circular motion, they can ask different types of questions. Means what? They will simply ask, explain the vertical circular motion. Also, they can ask, derive the expression for tension difference between the uppermost point and the lowermost point. Also, they can ask, derive the expression for velocity at uppermost position, lowermost position and middle position. So that will vary the numbers, means marks, that is 3 and 4 marks. So answer will be same, but some steps will get differ in these derivations. How? We will see in today's derivation, that is vertical circular motion. For this, we have to consider one body is making vertical circular motion. You know what is vertical circular motion, correct? This is the vertical circular motion. If I tie one stone in the string or one object of mass m in the string and revolve like this, this will be vertical circular motion. So here we have to consider 3 different positions. See, this is the center of the circular path. If this is the uppermost position A, center as O, lowermost position as a B, and middle position let us consider as a C. We have to derive the velocity at A, B and C, and also the formula for tension difference in A and B. Okay. So, if I consider this position, uppermost position A, which forces are acting on this body which is present at position A, that is mass which is present at position A. There will be 2 forces. First force, that will be weight force mg, which is acting in downward position, and also another force, that is TA, tension in the string. Correct? There will be 2 forces. One force, that is weight force mg, which is always in downward direction, and another force, that is tension in the string TA, will be also in downward direction, means that away from the body. In previous lectures, I have told you that tension in the string always act away from the body. Means we have considered this body which is present at position A. Away from that body, tension will get act. So TA and mg, both these forces are acting towards the center of the circular path. And we know that the force which is acting along the radius and towards the center of the path, it is nothing but the centripetal force. And if I consider this vertical circular motion, this circular path, this radius of this path will be r, that is OA distance will be r. Similar to that, this OB distance will be also r and OC will be also r, that is radius of the circular path. So here if I consider only this position A, then I can write the equation like this: TA plus mg is equal to mv square by r. This v I will take as the VA, that is velocity of object at position A. Therefore, TA plus mg is equal to mva square by r. Let this equation as equation number 1. Now, see, when you are revolving the string in vertical circular motion, at this point, it will get slackened. It will get slackened, means tension in the string will become 0. So at position A, this TA will be 0. So what I can write? I can write mg is equal to mva square upon r. M get cancel and VA square is equal to RG, means VA is equal to under root RG. Let equation number 2. And this is the expression for velocity of the particle at position A. Right? You understood the steps? Now, if I consider position B, at position B, there will be also two forces acting on this body. Which are that two forces? See, this will be here. Okay. Now, this force as a weight force mg acting on the body, and another force, that is tension in the string, and that tension will be act towards the center of the path. Why? Away from the body, right? This body is present at position B, and tension always act away from the body. Away from the body means towards this string is here, their potential will be here. Maybe downward, maybe upward, but here that will be in upward direction, that is away from this body and towards the center of this circular path. Means it is providing centripetal force for the circular motion. But this weight force mg is opposing that force. Correct? This tension TB, if I consider in the string, this TB get opposed by this weight force mg. Means the subtraction of these two forces will give centripetal force required for the circular motion. Means what I can write? I can write TB minus mg is equal to mvb square upon r. Right one? Velocity, I have taken vb. What will be the centripetal force? That is mvb square by r. But that force is the resultant of subtraction of TB and mg. Because TB is in upward direction, which is directed towards the center, means it is providing a centripetal force. But this mg opposes it. So I have to subtract that mg from TB and resultant centripetal force, that is mvb square by r. Let this equation as equation number 3. But from this expression, we can't find the value of VB because we don't know TB. Right? Here we have taken that TA as 0 because string is slackened here. We assume that. So here TB we don't know. So we can't derive the expression for VB like this VA. So what we have to consider here? We have to consider law of conservation of energy. That energy, total energy at point A is equal to total energy at point B. Which energy will be here? That is mechanical energy, kinetic energy and potential energy. So total kinetic energy and potential energy at this position A will be equal to total kinetic and potential energy at position B. So by law of conservation of energy, what I can write? Total energy at point A is equal to total energy at point B. What will be the total energy at point A? That is kinetic energy m1/2 mva square plus mgh. What will be h here? Potential energy having the formula mgh. So what is the value of h here? See, if you refer this figure, this distance is r and this distance is r. Correct? If I consider this as a reference position, this is the bottom point. Correct? From this bottom point, what will be the height of A? That will be r plus r. That is 2r. That is twice r. Correct? So h having value r plus r, 2r. So I have to write here mgh as a mg into 2r. That is equal to total energy at point B. What will be the situation at point B? Here kinetic energy will be 1/2 mvb square. See, 1/2 mvb square. But what about potential energy? If I take this point B as a reference point, bottom point, then height of the object will be 0. Therefore, h will be 0 and mgh will be equal to 0. That is potential energy at position B will be 0. So here that will be 0. Now m get cancelled. I have to find out this VB. Correct? So I will multiply these two towards the left side position. Means I will multiply these two terms by this 2. Also you can say multiply all the terms from both the sides by 2. What you will get? This 2 will here, 2 by 2, that is 2 will get cancelled, remaining only VA square plus 2 into 2, that will be 4GR is equal to this. 2 will become here, therefore only VB square will remains here. Now, what is VA? VA is nothing but square root of RG. So, put that value here, under root RG whole square plus 4RG is equal to VB square. Now, this square root RG means the square root and square will get cancelled and only the remaining term will be RG. RG plus 4RG, that will be 5RG. Therefore, VB square is equal to VB square is equal to 5RG. Therefore, VB is equal to under root 5RG. Let the equation number 4. Okay. So, this is the value of velocity of the object or the body at position B when it is moving in a vertical circular motion. Okay. Now, the remaining position is C. At the middle position, what will be the situation? There will be some amount of kinetic energy, some amount of potential energy. Here the maximum is the potential energy and minimum is the kinetic energy. When this body comes down, that kinetic energy will goes on increasing and potential energy goes on decreasing because height goes on decreasing. Therefore, at point C, there will be some potential energy and some kinetic energy. Again, we will use law of conservation of energy here. What will become? See, total energy at point A is equal to total energy at point C. Okay, so 1/2 mVA square plus again mg into twice r, correct? Height it is 2r is equal to 1/2 mVc square plus what will be the potential energy here? Sorry, say this height will be h. This h will be equal to r, that is nothing but the radius of circular path. So, what will be potential energy at point C? That will be mg into r. Now, m get cancelled. Again, if you multiply by 2 to both the sides, what will happen? See, this 2 get cancelled, therefore VA square plus 2 into 2, that will be 2 into 2, that is 4RG. This 2 will also get cancelled, therefore VC square only, and plus GR into 2, that is 2RG. Okay, so here we know again RG. What is that RG? No, sorry, VA square. VA square is nothing but the RG, that is velocity at point A. It is under root RG. Here square is there, square root will get cancelled and remaining term will be only RG plus 4RG. This 2RG will get minus 2RG is equal to VC square. 4RG plus 1, that is 5RG minus 2RG, that will be VC is equal to under root 3RG. Let this equation as equation number 5. If you observe these equations, see RG under root VA is equal to under root RG, VB is equal to under root 5RG and VC is equal to under root 3RG. If you observe this, you will get the idea that velocity of the particle which is moving in a vertical motion, it having higher velocity at bottom point, that is lowermost point, and it having highest velocity at lowest velocity at uppermost point, that is highest point A. At point A, velocity will be less. Greater than that, there will be at C, and greater than that, there will be B. Means highest velocity will be at bottom point and lowest velocity will be at uppermost, that is point A. You have to write that sentence, because if they ask the question that explain the vertical circular motion, you have to write this three equations. You have to derive these three equations, and beside this, again, you have to consider that tension difference also. Tension difference means they will you have to explain all the things regarding the vertical circular motion. So you have to consider that part of tension also. But they can ask, derive the expression for tension difference between the point A and B, uppermost and lowermost point. At that time, this section is not needed. You have to derive the expression at up to equation number 4, and then you have to subtract equation 1 from equation 3. Are you getting this? If they ask the question like, derive the expression for tension difference between uppermost and lowermost point in case of a vertical circular motion, at that time, you have to consider the derivation up to this point. You have not to write this part, that is velocity at point C, because we have to find out the tension difference only. So write the derivation up to equation number 4, and then you have to make the subtraction of this equation 3 and 1. Means subtract equation number 1 from equation number 3. Equation number 3 minus equation number 1. So what will be the step? See, TB minus mg will be as it is. Okay, minus this TA will be there. Minus this mg will be there, is equal to mvb square upon r minus mva square upon r. M upon r, it is the common term. Therefore, in bracket, there will be only vb square minus va square. Now see, we want tb minus ta. So I will write only tb minus ta towards left side. This minus mg will be minus 2mg, and that will becomes plus towards the right side. Therefore, that will be 2mg plus this m by r as it is. Now, vb square minus va square. What will be the vb square? That will be 5rg, because this root will get cancelled. 5rg minus this va square means rg. 5 minus 1, that is 4rg. Therefore, here there will be term as 4rg. R get cancel. Remaining will be only 4mg. This 4mg plus 2mg, that will be nothing but 6mg. Means what will be the difference between the tension? That will be 6mg. TB minus TA, that will be equal to 6mg. This is the expression for tension difference between uppermost and lowermost point. See, they will ask this tension difference only. If they ask tension difference between B and C, by logic, you can give the answer that tension difference between TC and TB, that is TB minus TC, will be 3mg. See, this is middle point. Okay, so we have to consider this half part. The tension difference between this full part, that is TB minus TA, is 6mg. Then TB minus TC will be 3mg, and TC minus TA will be 3mg. But definitely they will ask the tension difference between the bottommost and the uppermost point. That is, the tension difference will be 6mg. You understood the derivation? Simply first you have to draw this diagram correctly. Means the tension force and weight force, what is their direction? It is very, very important. And you have to know that the centripetal force is acting always towards the center. Means in this case, both are providing centripetal force. Therefore, I have taken the TA plus mg is equal to mva square by r. But at case B, what happens? See, here the tension force is acting towards upward direction and weight force is in downward direction. Means this TB is providing centripetal force, but this mg opposing it. Therefore, resultant centripetal force will be TB minus mg. Therefore, I have taken the equation TB minus mg is equal to mvb square by r. If you understood this concept, there is no any need of rectification. Are you getting this? If you understood the derivation, you can write it on your own. There is no any need of rectification. Understood? Okay, if you like this video, share and subscribe it, and also press the bell icon so that you will get the notification for next lecture, because in next lecture I am going to do the derivation for parallel axis theorem. Okay, so stay tuned. Thank you.